One of the most useful tools that we can do when we're dealing with forces is use the Polygon of Forces. This allows us to deal with a static system. Remember, the definition of a static system is that the sum of forces must equal 0 and the sum of moments must also equal 0. So we're just interested in the forces. So say we have, an object here and it's got three forces acting. We've got a force acting this way, let's make this 100 newtons. We've got a force acting this way and we've got a force acting that way. They're all working on this point. So we're going to set this up so this is nice round number. So we're going to make that right angle and we're going to make this angle 145 degrees. Now what we can tell is so sum of forces, if sum of forces equals 0, that means force 1 plus force 2 plus force 3 plus any other forces all equal 0. That's nice and simple. And if we're adding forces together, remember if we're doing this graphically, if we do this by drawing, and I like drawings let me, we add the vectors together nose to tail. That's force 1, force 2, so that's going to equal, so we add them nose to tail. So what we can do is if an system is equilibrium, if you add up all the forces and end up exactly at the same place you started, then the sum of forces equals 0. And we can use this knowledge to find missing forces and find the size and direction. So this video we're just going to concentrate with the direction of the forces. The next video we're going to determine what the sizes of the forces are. So let's take an example over here. We've got a 100 Newton force acting on this point and we've got two other forces. And what we want to do is make this into an arrow. So the first thing we do is we draw in the force we know. We know that there is a 100 Newton force acting here. So that's going to be 100 newtons. We know, because there's a rope there or whatever, that the forces must be acting somewhere along this. It must either be acting this way or it must be acting that way. We don't know. How can we do this? Well, what we do is, if this works with up to 2 unknown forces. So we add all the known polygon forces together, and then we draw in the line of action for the unknown. Remember, the line of action says what line is it working along, so we can draw it in along here. If you want to, you can draw a line of action up there. It's not going to make any difference. So I now know that there's force acting somewhere along that line. So it could be acting this way or it could be acting that way. And then what we're going to do is we're going to draw in, so that takes care of that force. This force here is acting at 45 degrees. So I connect that end up to the other end of the arrow, like that. So what I now end up with, so what I was saying is this line, we know the force is acting along this line, so I'm going to make sure that this force, that's the origin point, that's where we want to get back to, so I draw that line so it's on that end. So one of these lines is going to touch the tip of the arrow, one line is going to touch the base of the arrow. Now what I can do is I can draw around this. I can say, if I want to make a closed loop, I draw down there, I draw along there, I draw up there. So the two missing forces are, one goes this way, one goes this way. And then I transfer this to this. So this line, this is this force, I know this force goes that way. So I draw an arrowhead going that way. And to complete this triangle, it must go up there. Now some of you are saying, what happens if I put the force at the other point? Say instead of putting the 100 Newton force there, I draw it up here. So I draw the line of action in, it's going to touch the base. I'm going to draw the second line. And again we get the same triangle. And you'll notice that the forces, this force, if I'm going to go round the triangle to end up in the same place I started, I start there, I must go up there, I must go along there, that force is still that. And that's because remember, when you're adding, the order of addition is not important. That's why this works. And if you put these together, you'll notice this is the classic polygon of forces. So let's try another example. Let's make up what we'll do is if I have force acting down here, let's again make this 100 newtons, the size isn't, well, and let's say I have, I've got 3 ropes coming off here. I've got a rope going this way, rope going that way, again we'll make that, I've got a rope going that way, 45, and I've got that, make that 90 as well. So what I actually have here, and we'll make this one 50. Remember, this will work if we do not know two of the forces. So I know these 2 forces, so I've got 2 unknown forces. It works a lot easier if I only have 1 unknown force, but because I know this one, and I know this one, and I know this one is going this way, I draw in the 2 forces I know. So I draw in 100, because remember, force 1 plus force 2 plus force 3 plus force 4 plus equals 0. So here's force 1, I draw that in. Force 2, I draw that in. That's going to be 50. Force 3, well, and I know this angle is 90 degrees, so I add them nose to tail. Then force 3 is going to be at 45 degrees, and I'm going to start at the head of this one because this is force 3. I draw that up at 45 degrees. Cool. So I know the force is acting along this line. It could be going this way or it could be going that way. I don't know at the moment. This is what we're actually trying to determine. Now we know that force 4, if we look at this force here, what's the angle going to be between this force and that force? It's going to be about 45 degrees. So what we know, what I'm going to do is I'm going to draw a line, because remember, if we extend this line down here, what's the angle between here and here going to be? It's going to be about 45 degrees. I can tell this because I've got 90 here, 45 here, 45 here, and that's right angle, so it's going to be 45. I draw this size in like this at 45 degrees. And now, again, I just follow around the path. So I'm going to have a force going up here. That's going to be this force, so it's going to be going this way. And then this force is going to be going back up to here. So the polygon of forces, basically what we do is we take the forces, we add them together, nose to tail, we draw in the lines of action of the missing forces, and then we just follow it around. We go round in a circle, and that will tell us the direction of the missing forces. That's a very useful tool to use when you have to doing things like pin jointed structures using method of joints and things like that.